Yes, you are audible now. The last day we have discussed chemical kinetics, and last topic is
Sir, last topic that sir, orders of the different reactions were discussed. The difference between order, molecularity, and other some terms.
only base.
First order kinetic, second order.
First, second, third half life we have discussed.
Yes, sir. Half life we have discussed, sir.
Activation energy,
Yes, sir. Activation energy also discussed, sir.
activation Arrhenius,
RNS, yes, sir. Yes, sir.
catalysis.
Sir, catalysis. Just the things are discussed. The first thing, that what is a basically catalysis, and the and just preliminary things of catalysis was discussed.
Basic, yes. Okay. Yeah, let me start. Basic, introduce yourself.
Yes, sir. Sir, I am Subhajit Jana. I am from Purbo Medinipur district of West Bengal. I completed my class 10th and 12th from Nachinda Jivan Krishna High School. After that, I completed my BSc from Midnapur College Autonomous. Then I completed my MSc from IIT Guwahati. And sir, currently I am preparing for competitive exams related to chemistry.
Yes, good. Let's go through on chemical kinetics. Chemical kinetics is first topic is catalysis. Here, what the main application of catalysis and what the role of catalysis in Arrhenius equation? Describe.
Yes, sir. Sir, the catalysis, it is a process where a foreign substance that is added to the reactants to make the reaction faster. That the foreign substance is called catalyst, and the whole process is known as catalysis. So due to catalysis, the rate of the reaction increases. And Arrhenius, we have seen the Arrhenius equation. It introduced a term called activation energy, and the molecules need to attain the activation energy for the successful going through the product, that is the reaction happens when the molecules attain the activation energy. Now if we add a catalyst, then the catalyst actually does that. They react with the molecules and from different types of intermediates which have the lower activation energy, which have the lower energy of the transition state. So if we see the uncatalyzed reaction, it has the higher activation energy, and if we see the catalyzed reaction, it is multi-step, but there is lower activation energy. So catalysis does the changes the pathway of the reaction, and it drives the reaction through a pathway where the activation energy is very less. So, catalyst make the reaction faster by decreasing the activation energy.
Okay, what the effect of temperature on reaction rate from
Yes, sir.
catalysis?
Yes, sir. Sir, if that it has been seen that from the experiments, if temperature is raised 10 degrees centigrade, the reaction has been found that it increases 2 or 3 times rate is increased. And Arrhenius equation, it actually explains the why there is a increase in temperature, the rate of the reaction increases. If we see the equation, the rate constant K is equals to A e to the power minus EA by RT. So if we increase the term T, as the T is in denominator, so the total fraction that decreases on increasing temperature. And as e to the power minus EA by RT, so that is actually 1 by e to the power EA by RT. So if the power that decreases on increasing temperature, so e to the power also decreases. So overall, we see that as it is 1 by e to the power, so overall the thing exponential term that decreases, that increases on increasing temperature. As the exponential term increases, so the value of k increases, so the rate becomes faster. That is the mathematical explanation. Also there is a physical explanation. If we make the temperature higher, then from the Maxwell distribution we can conclude that the number of molecules having higher energy, the fraction of molecules having higher energy, that increases. So the collisions between the molecules become successful collision, and they can reach the activation energy and make the reaction happen. So this is the explanation why temperature increases, then the rate of the reaction also increases.
Yes, good.
Yes,
Next
sir.
one new topic is steady state approximation.
Yes, sir.
Is what the main application of steady state approximation in chemical kinetics?
Yes, sir. The steady state approximation, it is a process, it is a tool for the physical chemists. They use it to get the rate law when there is a intermediate which is short-lived and highly reactive. So they use a steady state approximation to obtain the rate law. The steady state approximation states that at the when there is a some concentration of the intermediate, the in the whole course of the reaction the concentration of the intermediate remains constant. So we apply DI/dt, that is the change in concentration of the intermediate with respect to time, that is zero. We apply the DI/dt equal to zero and get the equation and obtain the rate law for the particular reaction.
Yes. Next one is
Yes,
what the
yes.
difference between steady state approximation and equilibrium approximation in
Yes,
chemical
sir.
kinetics.
Equilibrium. Yes, sir. Equilibrium approximation, it is a tool when there is a intermediate which is long-lived and non-reactive. Then it has been seen that it actually attains a virtual equilibrium with the reactant. So there is a equilibrium between the reactant and the intermediate. So we use the concept of equilibrium constant by where equilibrium constant is equal to concentration of intermediate by concentration of reactant. So we use the tool and obtain the rate law. So this is called equilibrium approximation. So the main difference is that in steady state approximation, the intermediate that is short-lived and highly reactive, and in equilibrium approximation, the intermediate is long-lived and less reactive. So this is the main difference.
Yes, short-lived and long-lived. Yes.
Yes, sir.
Any drawback limitation of steady state and equilibrium?
Yes, sir. And if they are sometimes you have seen that using steady state approximation and equilibrium approximation, we get a approximated rate law. So actual by obtaining the particular rate law, if we see the exact result from the experiment that does not match properly for some reactions, but they are sufficiently good for obtaining the rate law. So there is a little drawback in the values, calculating values, but overall these are very good tools and very important tools for the physical chemists.
Yes, next one is Lindemann theory. Is what the main
Yes,
application
sir.
of Lindemann theory?
Yes, the Lindemann theory, it is applied for the to explain the rate of reaction of the unimolecular reactions. The unimolecular reactions, they might be bimolecular or unimolecular dependent upon the situation of the concentration of the reactant. So if we use the simple collision theory, then it must be second order reaction. Because there will be a collision between two A molecules and the concentration and the rate will be proportional to the power concentration to the power 2. But if we see, it is not like that. It sometimes it is second order, sometimes it is first order. So Lindemann proposed a mechanism where two A molecules collide to form a activated A molecule, and the activated A molecule have two chances. It might decompose if there is no deactivating collision, or it might get deactivated by another deactivating collision. So there is two possibilities. So using this Lindemann mechanism and steady state approximation, we get a rate law. And we use a approximation there. If the concentration of the reactants are very high, then there is a high chance of deactivating collision. So the activated molecule will deactivated faster, and the reaction will be fast order. And if the number of molecules are less, then there is a probability of deactivating collision is very less. So once the molecule get activated, there is a high chance that the molecule will produce a product, and the total mechanism that will follow a second order kinetics. So this is basically explained by Lindemann's theory.
Yes. What the effect from pressure, low pressure and high pressure?
Yes,
So
sir.
what is the order of
Yes, sir.
reaction?
when the pressure is high, then the number of molecules will be high, then the possibility of deactivating collision will be high. So at high pressure, due to deactivating collision, it will follow first order kinetics. But when the pressure is low, the number of molecules will be low also. So on low pressure, there is a less chance of deactivating collision, so it will follow a second order kinetics under low pressure condition.
Any drawback limitation?
Sir, the main drawback is that it is only applicable for the unimolecular reactions. Yeah, there might be, it cannot be explained by the other order of the reaction, cannot be explained from the other molecularity reaction, that is trimolecular or or bimolecular, that cannot be explained from this particular mechanism. This is the main drawback.
Next one is Michelmanson equation.
Yes, sir.
What the main application of Michelmanson?
Yes, sir. The using Michaelian-Menten equation, we can study the rate of a enzyme catalytic reaction with respect to the concentration of the enzyme and concentration of the reactant also. So this is the main application, and using the Michaelis-Menten equation, we can obtain the Vmax, that is the maximum rate at particular concentration. Also, we can calculate the turnover number K2. So using this law, using this Michaelis-Menten equation, we can get these types of terms, and also we can use Lineweaver-Burke equation. By modifying the Michaelis-Menten equation, we can get the from the slope and intercept, we can calculate the value of turnover number and Vmax also, that is maximum rate. So these are the applications.
Yes.
Yes, sir.
Yes, if Michelmanson is greater than substrate and substrate greater than Michelmanson, and Michelmanson equal to substrate, what will be the order of reaction?
Yes, the if the concentration of the substrate is sufficiently high, then there will be it will be very greater than Km, the substrate concentration. So then the substrate in the numerator and substrate in the denominator will be get cancelled out. So it will do not, the reaction rate of the reaction will be first order, and it will not depend on the concentration of the reactant, and with respect to the concentration of the substrate, it will be of zero order reaction. Okay, and if the concentration is less, that is Km is high, then there will be no cancellation of the concentration of the substrate. So the rate will depend on the concentration of the substrate, and it will be first order with respect to the substrate, and it will second order with overall, it will be overall second order reaction. And if S is equals to Km, then there we can cancel out the S, then also reaction will be zero order with respect to S.
Zero order and half order.
Sir, S plus
1
K2
by 2
into E0
Vmax.
into S. Sir, Vmax, then the rate will be half Vmax, then the rate will be half Vmax. I am telling about the order of the reaction. Order will be zero with respect to the substrate, but the rate, it will be, R will come K into E0, and that will be the, sorry, K into E0 by 2, that is the rate of the halves when the velocity is maximum, then it will be half Vmax of that particular condition when K2 is equals to, sorry, when Km is equals to S.
Yes. Any drawback
Yes, sir.
limitation of enzyme catalyst? Michelmanson.
Yes, sir. In this, we have used the steady state approximation. So, if we get the Max, if we want to the exact value, then we have to make the experiment happen. In from this equation, it will be little bit erroneous because we use the approximation there.
What is line wear work method? With
Yes,
what
sir.
the
In the
relation
line,
between line wear and enzyme catalyst?
yes, sir. The Lineweaver-Burke equation, it is the little bit extension of the Michaelis-Menten equation when 1 by V with respect to concentration that is mapped, and from the slope and intercept we can calculate the Michaelis-Menten constant also and V max also.
That's good. Next one is
Yes, sir.
next topic is collision theory. Yes, what the main application of collision theory in chemical kinetic?
Yes, sir. Collision theory, it is the one of the most preliminary theory in the chemical kinetics, where it in the collision theory it is applicable for a elementary reaction when two reactants A and B are there to form the products. So collision theory assumes that the molecules are like hard spheres and they are fully elastic, and to make the reaction happen, collision must be there between A and B molecules. The third approximation is like that the collision must be occur, and also the sum of the kinetic energy in the direction of their centers, the total kinetic energy, that will be sufficiently greater than a particular energy which is called threshold energy. The total energy should be greater than that to make the collision a successful collision. Not all the collision will lead to the product. And the fourth assumption is Maxwell-Boltzmann distribution of energy and velocity that will be maintained during the course of the reaction. And using collision theory, we can obtain a rate equation, and we can compare it with the Arrhenius theory. And using this, we can get a term, the frequency factor, that is pre-exponential factor. It will be proportional to root t. So Arrhenius assumed that the A and EA, the two terms are in Arrhenius equation, they are independent of temperature, but collision theory tells that it is slightly dependent on the temperature. So using collision theory, we can explain various reaction, and it is successful for some simple reactions, and it can explain it in a better way. But if there is a complicated molecule, that is polyatomic molecule, but then the polyatomic molecule that are not like spherical, they are not spherical, and they are not cannot be considered as hard spheres. So in case of them, the collision theory little bit fails to explain, because there is a possibility of that the collision might not happen between the two atoms which should be connected to make the bond. If we consider an example, nitrogen dioxide, the dimerization of nitrogen dioxide, that is, nitrogen dioxide is formed N2O4, then the collision must occur between the nitrogen, not nitrogen oxygen. So if you see the basic collision theory, it cannot explain the formation, and it cannot explain the rate. In the collision theory, we can obtain the rate of the reaction from the collision theory, but the actual experimental rate, that will be very less from the calculated from the collision theory, because there is a probability factor or steric factor. And also the collision theory, it cannot explain the complex mechanism and things of the complex reactions, and the in case of the complex reactions, they should not be like that. The experimental rate will be very different from the rate from the collision theory.
Yes, who by developed collision theory?
Sir, I actually forgot it, sir.
Arrhenius and Bontoff.
Yes, sir. Yes, sir.
What the drawback limitation of Arrhenius theory?
Sir, this collision theory.
Collision.
Yes, yes, sir. Yes, sir. Sir, in the theory, it is mainly applicable for the elementary reactions where only two reactants are involved. It can explain the things betterly. But if we see, it has the first assumption is molecules are considered to be hard spheres. But if there is a reaction between a triatomic or polyatomic molecules, then that cannot be considered as hard sphere because there might be a particular shape of the molecules. So, in case of some complex reactions, it cannot explain the rate better way. And there is also another factor called steric factor or probability factor because in case of the collision, the collision must attain the sufficient energy that is it has to exceed the threshold energy. But if it crosses the threshold energy, the reaction might not occur if the collision is not face to face for the particular bond forming atoms, because if we consider an example that is dimerization of nitrogen dioxide NO2 to N2O4, then the collision must occur between the nitrogen molecules. But if there is a probability, that is possibility, the nitrogen might collide with oxygen, so that collision might not lead to the formation of product, though it can cross the threshold energy. So it is one drawback. So the rate will be very much less, the experimental rate will be very much less from the calculated from collision theory. And also it is only applicable for the elementary reactions. So the rate of the complex reactions that cannot be explained from the collision theory.
Yes.
Yes, sir.
Next one is transition state theory, activated complex theory, or transition state theory. Yes, what the main application?
Yes, sir. It is the most advanced theory for the chemical kinetics. It can explain the rate in very much better way compared to the preliminary collision theory. In the transition state theory, it considers the reaction when the reaction happens due to the collision between the molecules, a activated complex or it is called transition state that is formed. And the transition state might go in the both the way. It can lead to the formation of product, and it can also might not formation of the product. The reactant can be formed from the transition state also. Now that energy of the transition state, it will be higher, and so there it will be in the, if we draw a curve, then there will be a saddle point where the transition state lies. Now if the energy is sufficient to cross the energy barrier, then the reaction will happen to form the products. And using the mathematics and other theories, we can calculate the approximate rate constant and the frequency factor or pre-exponential factor, and we can measure the value, and we can calculate from the transition state theory also. The values almost come similar, so it is very advanced theory. It can explain the reactions in a better way.
Yes. Good.
Yes, sir.
Yeah, transition state theory is K. It's called is transmission coefficient. Yes, what is transmission coefficient?
Sir, I actually forgot it, sir.
Yes, what the formula of activated complex theory? Product.
Sir,
Final product.
it states that the A, that is the frequency factor, it is equals to kBT by H. Kb is Boltzmann constant, and H is Planck's constant. So kBT by H into e to the power minus del Ng minus 1 into e to the power del S dagger by R. And the del Ng is called change in number of molecules and in number of gaseous molecules. So this is the value of A, and for calculating the rate constant, so K will be A, that is I have told the value, into e to the power minus EA by RT, that is activation energy by RT. This is the total formula of the transition state.
Yes, what's the difference between standard free energy change of activation, standard entropy change of activation, and standard enthalpy change of activation? What are the differences of
Yes, sir.
in
The standard Yes, sir. The standard in a enthalpy change for the activation, it is the change in total energy content for the for when the reactants are converted to the transition state. So this is the that energy difference is called total energy difference called in the enthalpy of activation, and the in the free energy change, that is the usable energy change during the formation of the transition state from the reactants, that is called gives free energy of activation, and the amount of entropy that is required to form the transition state difference, that is called the entropy of activation.
Yes, good. Next one, relation between activation energy and enthalpy of activation and temperature. For first order, second order, and third order.
Sir, please repeat the question again.
What are the relation between activation energy, enthalpy of activation, and temperature for first order of reaction, second order, third order? What will be the formula?
Sir, first,
Yes, activation energy is equal to del H plus RT. Activation energy, enthalpy, and temperature. So del H
so
standard.
the relation between del H and del S or something relation. So del H is
Relation
equal to del
between,
Ng
yes,
minus one.
yes, relation between
Yes, sir. Yes, sir.
activation energy and enthalpy of activation and a temperature.
Yes, sir.
First
That
order,
is the
second order,
relation
third
is
order.
yes, sir. Yes, sir. That is the del H is equals to del Ng minus one into del Ng minus one into RT plus EA, that is called activation energy. So del H is equal to EA plus del Ng minus one into RT. So if the change in number of molecules is 3 for third order reaction, then there will be 3 minus 1, that is 2 RT will be there. If there it is a second order, then 2 minus 2, so del H equals to EA, and if it is a first order reaction, then we might that is 1 minus 1, sorry, in case of second order it will be 1 minus 2, so that is EA minus 2 minus RT will be there for the relation.
Yes. First order reaction ये बराबर del H plus RT. Second order del H plus 2 RT. Third order 3 RT.
Yes, sir. Yes, sir.
Next one is what is salt effect? For the main application of salt
Ye-
effect.
Yes, sir. The salt effect, it is often it has been observed that if there is a reaction that is involved between the two charged species, or in a one charged species, one neutral species, then it has been seen that if we use some electrolyte in the particular solution, it might increase the rate of the reaction, it might decrease the rate of the reaction, or it might do not harm the rate of the reaction. So the addition of the salt that increases the that different that makes the reaction speed different. This is called salt effect, and we can use the relation, that is Debye-Hückel limiting law, to obtain the relation between them, and we use it, and we can get the charge, that is Z plus Z minus. It is depend on the particular substrates, and we can conclude the reaction will be faster or slower, or might not harm the reaction.
Yes, yes, good, good. Debye-Hückel
Yes, sir.
limiting law. You talk about the Debye-Hückel limiting law.
Yes, sir.
What is ionic strength?
Sir, ionic strength, that is called that the equation is half of summation Z Ci into Zi square, that is the concentration of the ith species into the charge of the ith species square, that is divided by 2, that is called ionic strength. And ionic strength, it is actually calculated to get the interaction between the different ions present in the particular solution. So this is called ionic strength.
Yes.
Yes, sir.
Is what the main purpose of salt effect in chemical kinetics? What the
Yes,
main
sir.
uses of salt effect in Debye-Lipkin limiting law?
Yes, sir. If we see the Debye-Hückel limiting law, it is log K plus minus sorry, it is log F plus minus, that is the mean ionic activity coefficient, that is equals to minus A Z plus Z minus into root I. The A is called the Debye-Hückel constant. The value of Debye-Hückel constant is minus 0.509. We use the equation and we get the conclusion from the, that is called Bonsted-Brenjam equation, and we get the value log k by k0, that is equals to 2a z plus z minus into root I. So the rate will depend on the z plus z minus value. So for the, if there is a reaction between two neutral species, so z plus z minus is 0, so there will be no salt effect. If there is a one species neutral and one species charge, then there also will be 0, so there will be no salt effect. If the both the charge is same charge, so z plus z minus will be positive, and so as the z plus z minus will be positive, so there will be an increase in the rate of the reaction adding salt. And if the one species is positive and one species is negative, then there will be total value will be negative, so there will be a decrease in the rate when we add the salt in the particular solution.
Yes, good.
Yes, sir.
Next one is what the difference between fast and slow reaction in chemical kinetics.
Yes, sir. Fast reaction are those reactions which concludes in very small time. Generally, the reactions which are very fast, that completes in 10 to the power minus 16 and minus 15 second. These reactions are called very fast reactions. Generally, the in the reactions where the oxidation state does not change, it actually are called very fast reactions. One example can be given as, if we add AgNO3 in a NaCl or HCl solution, the precipitation occurs very fast. So it is a very fast reaction. Also, the exchange reaction are very fast reactions. And very slow reactions, these are reactions which takes very large time to get concluded, like rusting of iron, and these types of reaction are called very slow reactions.
Next one is a chain reaction. And
The
how many
chain
types of
reaction,
chain reaction?
yes, sir. Chain reaction are those reaction that is also called simultaneous reaction, in which there might be a successive step, or there might be a branching of the reaction. So there will be more than one reaction. It is happening in a for a particular react process and or reaction. It is called simultaneous reaction or chain reaction. The simultaneous reaction can be of three types. One is opposing reaction, one is parallel reaction, and one is consecutive reactions.
Yes.
Yes, sir.
Parallel reaction and conjugative reaction. Yes, what the difference?
The parallel and consecutive.
Yes.
Yes, sir. The parallel reaction are those reactions in which there is a possibility of more than one product from a particular reactant. That is called parallel reactions, and the parallel reaction occurs, the product formation occurs simultaneously from the particular reactant. That is called parallel reactions. And one example can be given as when there is a nitration of phenol, orthonitrophenol and paranitrophenol forms. So these two products can be formed from a particular reactant, and it is an example of a parallel reaction. Also, there is another type of reaction that is called consecutive reactions, where one product is formed from a particular reactant and the product also decomposes to another product and with another rate constant. That is called consecutive reactions. Generally, most of the complex reactions are consecutive like reactions. If we get an example of SN1 reaction, at first the tertiary butyl group, it is tertiary butyl halide, it is converted to the tertiary butyl cation, and then it is attached with the halogen, attached with the alcohol, attached with the OH group to make the alcohol. So it is a simultaneous reaction. At first the intermediate is formed with a different rate constant K1, and after the formation of the intermediate, it is converted to the product. So it is a different rate constant K2. So it is an example of a consecutive reactions.
Yes, good.
Yes,
Next
sir.
two question is last two questions. What the beneficial point of chemical kinetics in our society, human being? Any 4 5 point.
Yes, sir. Chemical kinetics, it is the most important topic and which includes the study of the rate of a reaction and the mechanism of a reaction. So you knowing the mechanism or rate, we can in a very for various organic synthesis purpose, we can know that if the reaction is faster, then we can if there is a possibility of two reactions, one is faster and one is slower, we can apply, we can use the faster reaction to make the product effectively. Also, if the mechanism is known, then we can know about the intermediates. So we can design a particular synthesis route to get the product effectively. Also, from the kinetics, we can know about the rate determining step and other step also. So we can increase the rate of the reaction by knowing that which one is rate determining step. We can we can increase the rate of the reaction. Also, we can use a catalyst to increase the rate of a reaction, as catalyst decreases the activation energy of the particular reaction. And also using the concept of kinetics, we can explain the various phenomena. That is why there is no reaction occur between the woods and the oxygen, both are present in atmosphere, and both are connected. So we can get the idea about the kinetic barrier of a reaction, so we can explain the things in a better way.
Yes. The whole chemical kinetics and the drawback limitation.
Yes, sir. Chemical kinetics only deals with the rate of a particular reaction or rate of product formation or something, but it cannot conclude that from the kinetic study a reaction will happen or not. Kinetics cannot predict. To know this, we have to check the thermodynamic parameters. That is, we have to check the del G. If there is del G negative, then the reaction will happen. If the del G positive for the particular reaction, then the reaction will not happen. So feasibility of a reaction cannot be predicted by the chemical kinetics also. Or it cannot explain the stability of the product also. Stability of the product can also be predicted from the thermodynamics. So there is these are some drawbacks of kinetics.
Yes, good. Next, move on.
Yes,
Next new topic is electrochemistry. Yes.
yes, sir.
What the main application of electrochemistry?
Yes, sir. Electrochemistry is a chapter where we actually study the electrode potential, so that a part using the electrode potential concept, so that the reaction will happen or not, we can predict by knowing the electrode potential value. Also, we using the concept of the electrode potential, we design different batteries and other cells to using the to use the power of the particular from the particular chemical species. So production of electrical energy from the chemical energy, or chemical energy from the electrical energy, that can be concluded from the concept of electrochemistry. Also, and also we use different electrolytic reduction for in metallurgy. So the concept of electrolytic reduction, that can be known from the study of the electrochemistry also. Also, we can explain from using the study for a conductance study can be made. So we can conclude a conductometric titration or precipitation titration using conductometric parameters. So we can make the study of the particular and make the titration, and we can also measure the amount of the particular species present in a solution. Also, we can calculate the different parameters like equilibrium constant, degree of dissociation, solubility product. So different parameters can be calculated using the electrochemical study.
Yes, good.
Yes, sir.
Yes, good work from your side today. Next day we will discuss left part of electrochemistry and other is
Yes.
photo, chemical equilibrium and
Yes, sir.
quantum.
Yes, sir. Yes,
Yes,
sir.
thank you.